Welcome to Logarithms Part 3. What I'm going to do is I'm just going to show you how we can manhandle our way through some of these logarithm expressions and figure them out. So a little bit of basically some examples, see what we can determine here. So log base 7 of 7 to the 4. So, oh boy, well, how are we going to get through this? Okay. Not too bad if you just say, oh, I don't know what that equals, but I know another way that I can write this expression, and that is 7 to the unknown exponent, and that has to equal what I'm taking the logarithm of. So 7 to the question mark has to equal 7 to the 4. So then I look at this and I go, oh, well, I know what the question mark has to equal. Got to equal 4. So that means this whole thing equals 4. Now that's a pretty important little relationship. It kind of shows you a speedy way that if someone comes along and throws a similar type question at you, says log of 12 to the 9 base 12. You know, I don't really even have to think about it. I know the answer is going to be 9. So it just shows you kind of a nifty way. Once you've analyzed one of these, if you've got powers sitting here, they're not too bad to kind of work your way through. All right, next example. In this one, I've got log base 20, and then I've got 2 root 5. So I'm trying to figure this one out. Again, what you got to do is get out of this logarithmic version and say, well, this means 2 to some unknown exponent, or sorry, 20. 20 to the unknown exponent has to equal 2 root 5. Okay, so how do I analyze something like this? And probably the easiest thing to do is to take this mixed radical and blend it together and make it an entire radical. So what I'm going to do, I've got my square root of 5. I need the square root of something that is the same thing as the number 2. So that would be a 4. So let's keep working on this. This would now be root 20. And then I go, hey, can't I write this as a power? Can't I write this as 20 to the 1/2? Yeah, it means the same thing as the square root of 20. So what would my unknown exponent have to be? It would have to be 1/2. Okay? So again, get out of the logarithmic form, and then it gives you a very tangible equation that you can analyze. Okay, I'm going to throw one last example at you. Sometimes it's important to make an estimate, just to sort of see where we're at here. So I'm going to try to get a good estimate of something like this. Log of 10 base 3. So I'm going to try and go, yeah, I want to get an estimate of this guy. All right, so here's where I start. I go, I don't know what my estimate is. I'm just going to call it empty box. Now I'm going to get out of this form and go, doesn't this mean the same as 3 to the something? And that's supposed to equal 10. So this is my exponential version of this statement here. And it's with this that I can give myself a reasonable estimate, because I can go, well, let me see here. 3 squared is 9, which is a bit too small, and 3 cubed is a bit, well, quite a bit too big, because that's going to be 27. So in other words, my exponent here, if I want to keep it pretty close to the 9, just a little bit bigger than the 9, wouldn't 2.1 be a pretty reasonable guess? And now what I could do and say, well, I think that's a reasonable guess. How could I check it on the calculator? Well, it's really easy to check. I just go, well, let's try 3 and raise it to the 2.1 and see what we get. And I went ahead and did that, and I got 10.045. So yeah, it's a little bit too big, but you know what? That's pretty close. So that's a pretty good estimate. You know, certainly 2.0 is too small, as we know, 2.1 is a little bit too big, but it's pretty good as an estimate. So that's where I'm going to stop.